Hello, student. How are you all? I hope all of you doing very well. So now, student, it's a request of some my students. He demanded, sir, please arrange a class on two block system, right? Oh, hello, Divya. Actually, beta, I got busy somewhere, but Divya, beta, as I said, usually, beta, I can see YouTube live classes for those candidates, na beta, those are feeling needy and my support. So Aryan Misra, beta, I can say from Lucknow, he was going to LN Institute, Lucknow. He says that please make a video on two block friction problem for JEE Advanced because beta, 17th of May, beta, there is a JEE main, a JEE Advanced examination student. So now, student, today class is I'll discuss only problem idea, right? Okay. So students, what is the problem here? We'll go through one, everyone. Okay. So student, today class I'll discuss only numerical which are. So this is student first numerical only for my kids. They advance here. So student, question is what? First, I wanted to write question, student. My dear, first I'll write questions. Find F maximum such that such that both blocks blocks move together. Yes, Peter. This is the question here, right? So student, I'll take data here. So here my kids, I'm considering data. Data. This is the 4 kilogram. My dear student, this is 2 kilogram. Okay, fine. Student, what is the questions? Student, we have to find value of f such that these two blocks can move together. Right, my dear? Okay. Students, here I'm considering coefficient of friction, which is equals to mu, is equals to beta 0.2. Student, at this point, means you can say beta coefficient of friction between 2 kilogram and 4 kilogram, which is equals to, my dear, zero point 0.5. Right. Beta, this is the data of the questions. Okay. Students, here I'm going to solve here. This is entire part, beta. I can solve the questions only. Students, now I'm going to talk about solution of these questions. Right. In step one, beta, what is the way? What is the methodology, beta, to solve this question? Very unique, my dear. Concentrate on those blocks on which there is no any external force. Beta, keep in your mind what I'm telling you. Again, I'm repeating, my dear. Concentrate on those blocks. Beta, we have two blocks. One is 2 kilogram, another, my dear, 4 kilogram. Right? Beta, we have two blocks. In these two blocks, we have to concentrate on those blocks on which there is no force applied. External, my dear. So, beta, this 2 kilogram, there is no force at all. So, beta, we have to find friction force which is acting on 2 kilogram. Right. So, this is, students, you can make a BD of 2 kilogram. FAD, what implies, my dear? You can say you need to show all the forces which is acting on the block directly with that. So basically, we wish to find what is the friction force on 2 kilogram. So beta, I can say here, friction force because you are applying force over here. So what is the friction force on 2 kilogram? Student, friction force. Always we remember it's mu into L. It's not mu mg. Now since you can see beta as a BD, normal always acting perpendicular to contact surface. This is what, my dear, you can say mg. Simply you can write here n is equals to mg beta for this question especially. But always you can say friction means normal is equals to mg, but are not true, my dear. Right? So friction mu beta how much mentioned? 0.5 here. You can see this is 1 by 2. My dear, here I'm considering G is equals to 10. Until and unless if they will not mention in the questions, please don't take it. Right. So this is what beta n is equals to mg here. N is equals to beta g mg. So we can say m is what? 2 kilogram and g beta g 10 here. So we can write normal is equals to 20 newton. Don't forget to attach unit, my dear. So this is what 20 here. So you can say basically friction on 2 kilogram, that is what 10 Newton. Now, student, we have to also find what is the maximum possible force on 2 kilogram. Already we found here. So we have to find maximum acceleration here because we wish to carry entire block together. Behalf of this acceleration and behalf of this force. So beta here I'll write here acceleration maximum. That is what beta? You can say friction force per unit mass. So we can write, student, a maximum which is equals to 10 by 2, which is equals to beta 5 meter per second square. Beta step 1 finished. What you can do always be remember, I'm revising step number 1. Those who just joined newly, my dear, you have to concentrate on those blocks on which there is no force at all. Right? Okay, my dear. In step we are. Beta in step 2, what we need to do? Because beta, we wish to find force value of F. So now beta in step 2, now I'm considering, my dear, both block as a common system. So students, here you can say 4 plus 2 becomes 6 here. We don't know what is value of F. Let us say force applied on the block, which is equals to F. Beta, you are dragging, you are pulling the block towards right. So you can say friction force always, my dear, acting in left direction because all of you know friction is what? Relative motion. Students, you are trying to pull the block towards right. So you can say acceleration is also acting along the driving force. Right, my dear? Okay. So here I'm going to apply Newton's second law of motion. Summation of F net which is equals to ma. What is F net here? Applied force beta. This is driving force minus student. This is what? Friction force which is equals to 6. And AR we already found. That is what you can say 5. Right. What about this friction? Yes, beta. You can get it here. This friction beta. You can write here mu into L. Mu beta, what is mu over here? 0.2, my dear. So you can write 0.2. Normal, simply beta, I can say this is what? Normal always acting perpendicular to contact surface, and this is what? mg. So this is what beta, we can say 60 here. So this friction basically you can write, my dear, which is nothing but it's a 12 Newton. This is what you can say, but party 12 Newton here. So you can write that the friction minus 12 is equals to what here? 6 5 the 30. So F beta you will get 42 Newton. Means beta you can carry both block together if you will apply force on a system is equals to how much? 42 Newton. If force will be more than 42 Newton, so definitely system will not move together. System will not move together. But this is a, I can say, easy illustration. I hope all of you understood here. Now, students, I'm going to start here. Next pattern of question, but block based on two block system. Right. But have a look here. Next questions, my dear. What is the next question? Yes, beta. In this question, student, I'll give applied force on a block. In these questions, you have to verify the data. Either system will move together or not. How, my dear? Have a look. Student, here I'm considering here. This is the 5 kilogram block, right, my dear? Okay. This is students 2 kilogram block. Keep in mind, all unit here I'm using SI unit, my dear. Here, students, I'm applying force on a 5 kilogram, which is equals to 16 Newton. But a little yeah, just I'm going to twist in this question because it's the advanced illustration, my dear. So this is what you can say mu k. Mu k is equals to what, beta? Mu k can take here point 0.2. But on same surface, my dear, I'm considering this is what mu s, which is equals to student. This is what zero point 0.3. Done. Students, here again, I'll take my dear two data. That is what you can say mu k. Mu k beta, I'll take this is the zero point 0.5. And here, students, I'll take here mu s, coefficient of static friction, which is equals to zero point 0.6. I have question visible for each and every one. Now, students, I can say, beta, what we have to find this question here? Beta, in firstly, we have to find comment, comment on both blocks will move together if you will apply 60 Newton. If you will get a value will be more than 60, so you can say system will not move together. For that condition, students, you need to find individual acceleration of both of the blocks. Right, my dear? Okay. So what can you do, Matsya? Again, beta, concept remains same here. Student concept remains same. Now, beta, I'm going to discuss, or you can say I'm going to make solution of this question. Student, we remember, we have to concentrate on those blocks on which there is no force acting. So again, you can say upper block, which is equals to 2 kilogram. There is no force acting, right? So student, I'll go slowly here. I'll go slow, my dear. Okay, this is the 2 kilogram. Beta, this is you can say mu k. Mu k is equals to zero point 0.5. And another students, mu is also mentioned here. Just I'm drawing a BT beta for 2 kilogram. Students, mu s is equals to zero point 0.6. Here beta you can find individually here, Fk and Fs. Fk what implies? This is what I can say beta Fs implies static friction, which is equals to mu s into n. And Vachaji, you can say this is what? N is always perpendicular to surface. And this is what, my dear, mg. Okay, so N is equals to mgr. So simply you can say, sir, N you can take, this is nothing but, it's a 20 Newton. It's a 20 Newton. Now, students, basically, static friction here. Mu is mentioned how much? 0.6 beta. Zero point 0.6 student into 20, which is equals to 12 Newton. Now, students, similarly, I can also find coefficient, means kinetic friction here. So, Fk student, you can use formula over here, mu k into L. And beta will be same only here. That is what you can say, 20 beta z. So, this is, you can write zero point 0.5 into beta z 20. This is equals to 10 Newton. No, beta, what we have a target? We wish to find here, we wish to carry both blocks together only. So, we have to consider which we are going to find. That is the maximum acceleration of system. So, acceleration maximum student. This is what? But again, you can say, you can ask. Sir, we have two forces. One is a kinetic friction forces, other one is a static friction forces. Which one we have to take? Beta, we wish to find maximum acceleration here. Instead of, I can say this is what, beta, it's a mu s, fs here. But in fact, we have to take static friction because we want to carry both block together only, my dear. So what is the friction force here? You can say this is 12 y beta 2, which is equals to 6 meter per second square. This is the maximum acceleration value, right, my dear? Okay, step one, I can say this is finished. Now, students, I'm going to do step two of this part. What is step two, students? Here, I'll consider both block as a common system, my dear. Student, here I'll consider both block as a common system here. So 2 plus 5 becomes 7 kilogram. Now, here we have to verify system will move together or not. Behalf of 60 Newton. So for that condition, beta, you can take here any value of F. Let us say you are applying F force on 7 kilogram. Again, beta, you can say, sir, we have a two friction force over here. Means coefficient of friction. One is sir mu k, one is another one mu s. Which one I have to take? Student, system is in motion here. System is in motion. If system is in motion, my dear, then you have to take care only mu k, not mu s, my dear. Keep in your mind. Again, I'm repeating. But it's a confusing point which I earned from a student. Usually they ask in classroom physically, yeah, because you are not in front of me, so that I'm revising the same concept more and more than one time, my dear. So I can say mu k why I'm taking because this is what system is in motion. If system is in motion, my dear, so you can say kinetic friction will work. Kinetic friction will work, beta. So you can write here 5 plus 2 beta 7 and 7 to the beta. You can say this is what basically beta friction acting over here, which is equals to 14 Newton, which is equals to 40 Newton. Now, students, basically, what we have a target? We have a target to find value of F. Now you are beta applying driving force towards right. So we can say, bacha, this is what? Applied force, or this is what? Acceleration direction here. Now, student, I'm going to use equation of motion second. Summation of F net, which is equals to ma. So applied force beta, I can see system motion towards right here. So you can say this is a larger force. So F minus beta z 14, which is equals to 7 into 6. 7 6 yeah. 7 6 beta how much? 42 near. Ah, yeah, 42 only. So F is equals to beta how much here? This is 56 Newton. My dear, system will move up to only together. System, my dear, will move together up to 56 Newton. Right? If, but here applied force, how much? 60 Newton. Means pretty sure system will detach. System will detach. Right? Okay. Oh, Atharva, Hare Krishna, beta. How are you? Jai Sri Sham, student. Oh, many one. Okay. I'm good student. I'm very good here. Actually, but I'm quite busy in the classroom, so I couldn't revert anyone. Okay, very good. Very okay. Atharva, what about your study, my dear? Atharva, doing well, Ucha. Doing well. What about your study, student? Atharva. Okay, now beta. We continue, bacha. So here, beta, I can say step three. Here, I'm going to do, my dear, because both of the block, because it will move individually, not together. Okay. Uh, true. Many one, Atharva. Many one, beta, I can say it like you, bacha. Many one, not only one candidate from your classroom, beta. Many parents, many kids, sir, nowadays physics in coma only. Yes, Atharva. Okay. So, beta, we concentrate here. So now, student, I'm going to find here, beta, acceleration individually. So beta, first I'll concentrate to find my dear accelerations of 2 kilogram. Right, beta? Okay. Oh, yes, yes, yes. Hmm. Okay, beta, I'll try to come here on YouTube. No, beta, it's a request by kids here. Already said Aryan Misa from Lucknow here. He requested for the class here. So I can see I canceled my online classes and now I'm taking this class here. So, beta, you're pulling block towards right here. So, beta, who will carry 2 kilogram? Only beta, this is what? Only kinetic friction here. Beta, what is the kinetic friction, students? Mu into n here. So, you can say, beta, already I calculated here, which is equals to 10 Newton beta. So, I'll use directly my dear. Right. Okay. Okay. You're waiting for class. Good, 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 good. Beta, I'll try to come here on live. This is beta, the 10 Newton here. So students, here you can say this is the direction of acceleration of 2 kilogram. So here you can write, my dear, acceleration of 2 kilogram, which is equals to force per unit mass, which this is 5 meter per second square. Now students, in step 4 here, my dear, I'm going to find acceleration of 5 kilogram, right? So, student, there is no action reaction pair is applicable. Beta, if this block moving right here, they will apply on 5 kilogram friction in left direction. So, this is what beta 10 Newton because of 2 kilogram. Right. Now, students, there is one more friction because this is what remains in contact here. So, 2 plus 5 becomes 7. System is in motion, students. So, here again you can take this is what beta is 14 Newton here. I'll repeat here this point because it's a confusing point by the kids. Beta 10 Newton because of you can just keep in your mind it's an action reaction pair, sir. Right. How it came beta 14 Newton? It's a very simple logic, my dear. Beta 14 Newton just because they are remains in contact. If you will apply 60, then they will detach. So due to this condition, students, you have to take here entire mass, not only 5 kilogram. It's I can say very common doubt among the student. So now beta, I can say here, now you are applying force how much? Which is equals to 60 Newton. Right, my dear? Entire system beta will move in the right directions. You can say acceleration A. Right. So here students, acceleration of beta G 10 kilogram. You can write applied force. This is driving force is 60 minus students 24. Upon beta ji, how much here? What is the mass? It's 7 kilogram here. 7 kilogram. So how much can my dear? Tell me everyone here. This is 5 near. 5 near. Okay. So whatever beta coming here. This is answer of the question. It's a, I can say good question here. Yes, my dear. It's a good question, student. Now, students, again here, I'm going to move my dear on next questions. Right. So I can see these are the student fundamental question here. So you can keep in your mind. Now, students, again here, I'll take data. Questions remain same. You need to verify system will move together or not. If not, for that conditions, you have to find individual acceleration. Right, my dear? Okay, so what's the questions here? Have a look, my dear, everyone. Okay, student, there are again here. Students, here I'm considering there are two blocks. Here you need to verify system will move together or not because I'll give you applied force on a block. This is my idea 2 kilogram. Yeah, this is I'm considering 1 kilogram. Keep in your mind. I didn't, but yeah, it's understood 1 kilogram. Now, students, I'm applying force on 2 kilogram, which is equals to 18 Newton. Student, here I'm considering mu k, which is equals to mu s, which is equals to beta point 2. Beta, in between 1 kilogram and 2 kilogram, I'm considering mu k, which is equals to zero point 0.5. And newest student, here I'm considering point 0.6. What is question here? Again, I'm repeating. Students, you need to verify system will move together or not. If not, for that conditions, you need to find individual acceleration. If they will move together, then you need to find common acceleration. I hope you got it, the questions. Now, students, have look here. I can say for solution of the questions, right? Okay. So here, students, I can say, my dear, concept remains same here. You need to concentrate on those blocks on which no external force acting on the system. So this is what students 1 kilogram. Here, beta, you can find here because here mentioned in the questions mu k, which is equals to zero point 0.5, mu s, which is equals to zero point 0.6. So here you can find beta two forces over here. One is the static friction, another one beta you can say kinetic friction here. Friction static students, you can say this is zero point 0.6 into 10, which is equals to 6 Newton. Beta kinetic frictions, you can say student, this is mu k into n, which is equals to zero point 0.5 into 10, which is equals to 5 Newton. You know, beta, we want beta carry to block together here. So for that condition, beta, you need to find maximum acceleration. So a maximum beta, what you can say? Again, here, force per unit mass. Which force you have to take? Again, beta, you have a one friction force, static, one friction force, kinetic. We wanted to keep system together here, so we'll take maximum force, which is equals to, you can say 6 by 1, so you can say 6 meter per second square, beta g. Now yeah, this is step 1 beta done. Now students, I'm going to just moving ahead here, next part of these questions. Here students, I'm considering both block as a common system, so 2 plus 1 beta becomes 3. Now, student, this is what we don't know yet because we have to verify system will move together or not. So here I'm considering F. Now, students, you are trying to pull the block here towards right, means you are pulling acceleration A. So what about your hair friction? There is no segregation because the mu k vs both are remain same only. So 30 into zero point 0.2 here. How much you can say, bacha? Tell me. This is what you can say, bacha ji, 6 Newton. Right. Students, now here I'm going to apply equation second law of motion. F net, which is equals to ma. So what is F net here? F minus 6 is equals to beta 3 into 6. Right now? 3 6 are 18 plus 6 are 24. How much you can say here? This is what beta you can say 24 Newton. Oh, it's very good. It's very good thing for us, beta. System will move up to 24. How much you applied? Only 18 here. So what you can say now? You can say, my dear, system will move together. System will move together. Right. So students, for this condition, in step 3, now I'm going to find common acceleration. How can we find here? So this is what a student, both block you can take as a common system, my dear. 3 kilogram here. Applied force beta how much? 80. What is the friction force over here? Which is equals to 6. Which is equals to 6. The entire system here will move to in a right direction. So you can say summation of F net, which is equals to, my dear, MA only, right? So we can see here further, that is what students, 18 minus 6, which is equals to 3 into 6 beta. How much? Okay. Okay, what you did here? We wanted acceleration here. Then how can we do? A only here. 18 minus 6 beta. How much? You can say 12 by 3, which is equals to A. You can solve, my dear, further here. You will get 4 meter per second square. Student, this is what you can say acceleration common. For both block will move together with accelerations 4 meter per second square here. Now, students, again here, my dear, move on a next questions. Right. Questions remain same, but this time I'll change yeah, little data. Right. Students, I can say this time here I'll apply force on upper block. Little tough only, but imagination here. Means understanding is good for these questions. Required students. If you are a very good thinker here, then you can do these questions. Student, this is what? 4 kilogram. Now, this is what? Students, 2 kilogram. Now, in this question, student, I'm applying force on upper block, which is equals to 9 Newton. Beta, there is no frictions. You can take mu is equals to 0. Here, students, I'm considering here mu k beta, which is equals to 0.4. And this is mu s student. This is equals to zero point 0.5. Right? This is the questions. Now, student, in this questionnaire, what we have to do? Comment on system will move together or not as per applied force 9 Newton on 2 kilogram. First things, if not, then you need to find common acceleration of both of the blocks. Right, beta? Okay, fine. Students, few concepts here remain same. Beta, in solution, step number one. Beta, you need to concentrate on those blocks on which there is no force acting at all. So you can say clearly, sir, on 4 kilogram, there is beta, you can say there is no force acting, right? If there is no force here, then beta, we have to concentrate on 4 kilogram. This is what, my dear, you can say this is the 4 kilograms. Now we can think who is responsible to drive this 4 kilogram? Only because the friction between these two blocks. One beta, you can say this is what? Kinetic friction here. So this is 20 into 4 here, 8 Newton, 20 into 5 here, 10 Newton. So maximum force because we wanted to carry both block together only, right? So here students, you can say this is what, my dear, only 10 Newton, which is a static friction, right? So here students, you can write acceleration maximum of system, which is equals to 10 by 4, which is equals to beta 2.5 meter per second square. Oh, no, 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 beta. What is SR01? No, beta. I remember everyone here. Actually, what's the symbol for my own kids? If I taught you, or if you are knowing me, so what is the greetings initial? Jai Sri Ram or Hare Krishna? You didn't know beta, so I didn't recognize by your email ID and all here. No, no, beta. Remember SR01. How are you, beta? SR01, how are you, kids? Okay, so beta, this is what acceleration here, 2.5. Now, student, in step 2 here, what we will do, beta, we'll take both block as a common system. So 2 plus 4 becomes how much, my dear? This is what? 6 kilogram, right? Okay. So here we want to just verify either system will move together or not. So you can take any values of f. But I already know there is no friction at all here. So mu is equals to 0. You are trying to pull the block towards right here. So acceleration also in towards right direction. So you can write over here summation of F net, which is equals to MA. So beta, you can say here for this condition, F net mass is 6 beta and this is 2.5. So F net means applied force on a block which is equals to 50 Newton. Okay, again here very means it's a good, very good for us. System beta can move together here up to 50 Newton if you will apply on a block, right? But how much you applied? You applied beta only here. I can say that is what 50 Newton. So students here it's easy question for us here. For these conditions, you need to find a student what is the common acceleration. What is the common acceleration here? So student for common acceleration, simply can draw both block as a common mass, common system, 6 kilogram and this is a 9 kilogram. Means 9 Newton here, my bad. So again, beta system you are trying to pull towards right only. So students, again you can apply here equation of motion second F net is equals to ma. So acceleration is what, my dear? You can say F net upon, or you can say F external here, more good for us. Yes, beta. F external here. F external beta upon mass here. So what is F external? 9 by 6, which is equals to 3 by 2 meter per second square. Beta, this is the, you can say, value of acceleration for this condition. Both block can move together with common acceleration. Beta, the maybe here they can ask, what is the friction between the block? Right. So beta, find friction between the blocks. Beta, because both system will move together here. It's pretty understood. What you can say, sir, here we have to find what questions here? Find friction force, find friction force between two blocks. Right. So here students, there is only a static friction here. So here you can write student friction static, which is equals to M into A. And what is beta mass here? Because here we are finding, my dear, between this the 4 kilogram and acceleration is equals to 1.5. So you can say friction beta A, that is what student static, which is equals to beta 6 Newton. So in this question here, I added one more part, that is friction between the block. Now students, again here I'm going to solve two block system questions only. No beta, method remains same everywhere here. That is a common questions. Right. Now students, just move, my dear, on next question here. Questions remain same, bacha, but this is your homework here. I'll not solve this question, bacha. In the classroom here, usually I have to avoid common frame of questions here. I'll give little twist in this question, but you can do if you understood what I taught. Students, this is, you can take 2 kilogram, 5 kilogram. Here, my dear, I'm applying force on 2 kilogram, which is equals to 20 Newton. Students, here I'm considering mu k is equals to zero point 0.4 and students mu s is equals to zero point 0.5. Here student mu k you can take zero point 0.5 and this is what mu s beta z zero point 0.6. Questions remain same. Students, you need to verify. Oh, Nuria, how are you? Very happy to see. Many joined just now. Okay. Come, my dear. So this is what US here. So, my dear, this is your homework questions. You can do. You have to solve and write your answer in comment section under this video. Right. Okay. Very good, beta. I'm very happy to see you there, beta. Okay, fine. Now, beta, next questions here. So, Nuria, beta, we concentrate beta further. It's beta very, very helpful, my dear. Will help you a lot. Okay. Now, Bachaji. So, this is I'll beta go little slow so that you can understand beta. Now, what's the question, students? In this questions here, I'll take little different data. Nuria, beta, you got delay. So, beta, I can just watch this lecture here from beginning. You will enjoy it here. Beta, highly important. Yes, highly important, beta ji. This is beta 4 kilogram. Now, students, another block, I can say above of 4 kilogram, which is equals to 2 kilogram. Students, on 2 kilogram, I'm applying force 20 Newton. Beta, on 4 kilogram, I'm applying force 30 Newton. Beta, here I'm considering here mu k, which is equals to zero point 0.4. Students, mu s here, I'm considering this as a zero point 0.5. Any more data? Let it be. But I'm be simplify more here, this question. I'll complicate in next questions. You can take it as mu simple here, which is equals to zero point 0.2. And here, students, mu is equals to zero point 0.5. But you know, what is the question here? Because we have to comment. Comment both blocks will move together or not. If not, for that conditions, yeah, we have to find different acceleration. If yes, then they will move together. But I'm telling you, but for pattern of these questions, always pattern of this question, students, always. Uh, Hello, beta. I can say I'm not able to recognize the name. Maybe SN. Maybe SN. Happy to see, my dear. Beta, for this condition, yeah. Just listen, beta, carefully. Beta, for this pattern of questions, you need to consider both block as a common system. Beta, in step one. In step one, student, both block you need to consider as a common system. First case, beta. So 2 plus 4 beta, students. Nuria, 2 plus 4 beta ji. 2 plus 4 is equals to 6. Beta, reply in live से Nuria बच्चा दिन will enjoy beta. 2 plus 4 is equals to 6. Now, yeah, how much force you are means already have considered? That is what 50 Newton. Now, students, we can talk about friction force. How much over here? So 2 plus 4 beta ji. Friction force always keep in your mind, which is equals to mu m. Mu beta, how much here? This is zero point 0.2 and normal beta g, you can say mg, which is equals to 60. Beta, here I'm considering j is equals to 10. So students, friction you can write basically 12 Newton. Friction is equals to students 12 Newton. Oh, very good, beta students, very good. Okay. Now, students, here you can write here. This is a 6 Newton. System, my dear, motion towards right. So, student, again, here, we are targeting to find what is the value of A. So, students, you can apply equation of motion second beta. Already I taught you beta for unbalanced system here. F net which is equals to MA. Student system motions towards right here. So this is a driving force. So tell me, my dear, I have to write here 50 minus 6 or 6 minus 50. Student, here I have to write 50 minus 6 or 6 minus 50. Okay, okay, okay. 12 is your answer, beta. Now, beta. So this is what you can write, beta ji. 50 minus 6 is equals to beta ji 6 into A. Beta 50 minus 6, beta how much? 4 plus 2, 6 नहीं यार 6 to the 12 बेटा जी my bad यार this is 12 मीटर you correct बेटा Nuria, you correct, beta. You correct, my dear. Yes, you correct, beta. Because of me, we are also I corrected, beta. That's why God bless you. 50 minus 12 is equals to 6 into a beta. So this is what you can say 38. 38 by 6 is equals to acceleration, bacha. So A you can write, bacha ji, this is acceleration here. A. So A you can write, bacha ji, this is 19 by 3 meter per second square. Very good. Very good, beta. I mean, there is no difference, student, especially I can say, Nuria, you are the candidate replying in the classroom. Means you reply here, you are the candidate replying in live session as well. Beta, go ahead. Beta, go ahead, yeah. Right. Now, student, step one, beta, finish, Nuria. Now, student, now have a look, I can say, for step two. Right. But what is step two here? But in step two, what you can take, but as we go individually. Beta, for this condition, what is the friction force over here? Tell me. 10 Newton? Agree? Beta ji, what is the friction force over here? 10 Newton, bacha ji. And here, bacha ji, 12 Newton. Here, beta, what you can say? 12 Newton. So I'll verify here. How this is? Have a look. Students, this is the 4 kilogram. I'll verify friction force is coming this much or not. If not, means what I consider that is wrong. But as a 4 kilogram, and this is what, my dear, I can say 2 kilogram. Right. Here, yeah, you can say applied force is 20. Students, here I'm considering here. This is what? Beta, friction over here. Right, beta? Here I'm considering here, this is what? Friction, which is equals to F. Okay, so but I'll be verified, beta. Then beta ji, what you can say again here, system beta motions towards right only. So beta you can apply here this condition. 20 beta, just beta you need to just verify this friction on 2 kilogram. This is the two students. This is the 20. This is the friction. So system beta motions towards right only. So student again you need to apply some equation of motion second F net which is equals to ma beta, right? Okay. So F net students here again you can write 20 minus friction force which is equals to 2 into 19 by 3. So 20 minus friction force beta ji 38 by 3. So students, you can just solve further here. Friction is equals to 38 by 3 minus 20 beta. So we can see further here, student, friction is equals to 38 minus 60 by 3 beta g. Right. So this is what beta coming here, 38, 22. So minus here. So finally you can write beta here, yeah, answer you can write friction is equals to 22 by 3 Newton. This friction basically beta we found in between these two blocks, 2 kilogram and 4 kilogram. And what is the actual friction value over here? This is what 10 Newton. This is what 10 Newton. And 22 by students, what we found 22 by 3 Newton less than 10 Newton. Means student, what you considered your assumption is correct. What implies this one? Means system will move together only. System will move together. Very good, 22. Very good, very good. I'm very happy to see beta. I can say all of you candidates in the live session as well as in classroom replying regularly, my dear. I'm proud on all of you. Okay, now students have a look at next questions. Right. Again, students, I'm giving you one more questions for your self practice. You can do beta at home so that yeah, you can see are you getting live session or not. Students, here I'm considering this is 3 kilogram. My dear, this is 2 kilogram. Okay. Students, here I'm applying force here. You can say this is 10 Newton. This is students, I can say 20 Newton. Here you can take beta. Mu is equals to zero point 0.5 and here you can say zero point 0.6 you can take. Zero point 0.6 and here beta mu is equals to zero point 0.4. Questions remain same beta. We have to verify our answer. Beta either system will move together or not. If not, for that conditions, you need to find individual acceleration. If yes, beta G, for that conditions, you need to just proceed the questionnaire. So, my dear, this is your homework questions. Right. Have a look, my dear. Next questionnaire. Okay. So this is students. Next questions. Now, students, you can just take as a consideration. This is a kind of arrangement you have. Right. This is a 2 kilogram idea. It's a very good question, students. Really a highly good question. My dear, this is 2 kilogram. Now I'll take this is the 1 kilogram. Students, here I'm applying force on a block which is equals to 40 Newton. Here, students, you can take mu is equals to zero point 0.4. Here, students, you can take mu is equals to zero point 0.2. But a question here, it's a pretty good question. Student, this question here again, comment both block will move together or not. If not, then we can find individual acceleration. If yes, then we have to find common acceleration. That much. Student, maybe these questions look like out of syllabus, or you can say out of your concern and your potential. But literally, beta, it's a pretty easy question. Pretty easy, my dear. How, dear? No, this question, beta, basically they are hanging. They are hanging like this. Student, for this pattern of questions, you try to keep on a horizontal plane. It's more better for you. How beta? Step one beta. I'll do step out for this question because it's a, new pattern of questions, my dear. This is what you can do here. Try to beta keep entire beta hanging block on a horizontal plane for easy solution, students. This is 2 kilogram. This is 1 kilogram. Beta, it's hanging here. So how much force over there? 2G, which is equals to 20 Newton. 1 G beta. So you can see on 1 kilogram, there is a force 10 Newton. Now, beta, you need to calculate what is the friction force over here. Beta, keep in your mind here. Formula of friction force. Student, friction force is equals to what beta? Always keep in your mind here. It's a mu into n. It's what beta mu into n here. So beta for 1 kilogram, this is a normal force. Don't take this one is a normal force. Not at all, my dear. Keep in your mind. It's beta very good thing here. Beta, it's a very good thing, my dear. Beta, this is the normal force. Normal force, you remember everyone, always acting perpendicular to contact surface. So beta, normal acting in this direction here. So normal is what? Opposing to 40 Newton. So normal simply you can say for this question, for this particular question, my dear, simply you can say normal is equals to 40 Newton. This is the conditions, my dear. Right. So first here I'll calculate friction on 1 kilogram. Then beta I'll calculate friction on 2 kilogram. So beta friction beta you can say this is what is the mu on 1 kilogram, that is zero point 0.4. So zero point 0.4 into beta g you can say 40. So friction force over here, beta, 16 Newton. You can write students are here. Friction force is equal. Keep in mind, it's a very good question. Very good question, bacha. Listen carefully here only. So beta, I can say here friction is equals to 16 Newton. Now beta, I'm going to find here friction on 2 kilogram. So students, again here, I'll use the formula. Friction is equals to mu n. But this is the friction air on 2 kilogram. So what is the mu? It's a point 0.2 student. Normal beta, already I see it here. This is the 40 Newton. So you can say this is nothing but it's 8 Newton. So beta on 2 kilogram friction force with means I can say in contact with the surface, this is 8 Newton. It's very easy beta to solve here. Just keep in your mind it's a friction force. Keep in your mind, my dear, it's a friction force. Again, beta, same approach can apply. If you are not able to understand what is the steps for these questions, don't worry. Beta, step one, beta, finish. Student in step two, always keep in your mind. For this pattern of questions, you need to take both block as a common system. Yes, always, always you can apply this pattern of concept, students. So 2 plus 1 becomes 3 kilogram. What is the total force acting on the block? Means you can say applied force. It's not applied force, but just you can take as a consideration for understanding only. This is what 30 Newton. This friction, there is no role for, I can say, motion of the block. These frictions only oppose the motion of the block. So you can say, bacha, in this direction here, how much friction over here? This is the 8 Newton. System motion, student, that is what towards right. So you can say summation of F net is equals to MA. Definitely, how much here? System driving force, my dear, in this towards right here. So this is a more larger in magnitude, 30 minus 8, which is equals to 3. How much students coming? 22 by 3 meter per second square, which is equals to acceleration. My dear, which is equals to acceleration, right? Okay. After that, beta, you need to verify either friction force is coming 16 or not. If beta, you will calculate friction force between 1 kilogram and 2 kilogram, and you are getting less than 60 Newton. Then you can say what you considered, what you have taken assumptions to solve the questions, that is correct only. That is correct only, beta. Okay, so student, in step 3, I'm going to do what a student. I'll verify friction values coming 16 or less than 16. If less than 16, then you can say what we have considered that is a true only. Right? Okay, come idea. Students for 1 kilogram. Make your ABD of 1 kilogram. What's the applied force, student? This is the 10 Newton. Friction force here, you can say here. So beta, here I'm considering this is the direction of friction force. Motion beta system towards right only because this is a driving force. Now students, I'll apply again here equation motion second summation of F net which is equals to ma. F net, this is what? 10 minus friction force which is equals to here 1 into 22 by 3. So you can say minus friction is equals to 22 by 3 minus 3, minus 30 here. Minus 30, 22. 8 by 3. Am I right? Students, am I right here? Tell me my calculation is correct or not. If you present in live session, student, please respond me 8 by 3 Newton. Friction is equals to students. This is 8 by 3 Newton. Perfect. Which is you can say less than 16 Newton. Friction here, what we considered, which very good. Thumbs up. Very good, beta. Keep it up. So, beta, what we consider here? Because what we have taken consideration, beta, we consider entire block moving together. It's true only because we calculated friction force and friction force what we got 8 by 3 which is less than 60 Newton. So beta what we considered here your assumption is correct. Your assumption is correct. Yes, yes, very good. Very good beta. Be active here. Then you will enjoy the session here. Then you will enjoy beta. Oh, HF, how are you, Vita? Vita, God bless you for your very nice comment here in the live session. Very good. Now, students, then here, because what we have taken, bacha, so we have to find beta common acceleration here. So, students, we have to find students acceleration common. What about acceleration common, bacha party? 30. But I can make here, but both block as a common system. But I'll do here, yeah. Yes, beta. 2 plus 1 students 3 and 20 plus here beta what you can say 30 Newton here. So you can apply beta as this is the 30 Newton and this is 8 beta. So you can say system beta motion towards right only here. Right. So what is the common acceleration beta for this question here? I'm solving my dear. Acceleration common beta for this question. This is 30 minus 8 by 3. Beta, how much coming? Tell me, beta. HF, HF beta, SN 22 by 3 Newton. Very good. Maybe SN you are. Maybe SN you are. Yes, SN only. Okay, very good, yaar. I'm very happy to see, bacha, all of you are literally very much active in live session as well. Okay. So now, students, I'm giving you one more numerical for your homework, students. Very good. Very good, beta. Acha, Nurian, Simran, Eshan. Okay. Who is this, beta? Uh, I'm not getting. Maybe HA. Beta, again, yeah, one more, beta. I can say homework, beta. This is, beta, numerical homework, beta. This is second one. Third, beta, I'm giving you everyone. The questions remain same. You need to beta verify either system will move together or not. Yes, beta ji. We'll go through this here. Uh, no, 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 no. No beta HF. I'll change the question here. Yes, beta. You can take beta. This is 2 kilogram. This is a 3 kilogram. My dear, here I'm applying beta force which is equals to 50 Newton. Mu is equals to beta point 2. Here beta ji mu is equals to point 0.4. Show me beta this question solutions tomorrow beta. Those who joined live session, show me beta solutions tomorrow morning in the classroom. Yes, this question. This question bacha. If you got delay bacha, SN. Oh, very good SN bacha. Very happy to see my dear. So beta, we remember everyone homework which you can show me tomorrow. If you are getting delay, if you are not able to understand, just go watch again here because I have another things students. Yes, tomorrow, Sumi Bacha, all of you do join me. Any doubt, Bacha party, I'll see you. God bless you, Bacha. Now I'm going to close this live session, Bacha. God bless you all.